Okay, first hour, Algebra 2. Today we're going to use our SOH CAH TOA in a different way. We're going to use it to find angles, where yesterday we found sides. Okay, now I'm going to do the video or the notes this way because I thought there was too much writing for you guys to do. So we're going to, I've included a copy of the teacher notes, this copy you're seeing in the stream or in the classwork, so you can use those to go along with this video. But yesterday, you had all these problems yesterday where we set up this little proportion here, sine of 40 equals x over 15, something like that, okay? But what we want to realize is all day yesterday you did the sine of an angle equals some number. It was always this setup. Matter of fact, it was any trig angle equals, or any trig function of an angle equals a number. So your problem set up like the sine of an angle equals a number. And what was that number for the sine? Well, it was an opposite over a hypotenuse. The cosine of an angle equals a number. And what was this number? Well, it was a fraction, whatever the adjacent over hypotenuse was. And we had tangent of an angle equals a number. And what was that number? Well, it was some fraction that was an opposite over adjacent. So everything yesterday was a trig function of an angle equals a number, okay? And that's when we were finding sides. Today we're going to find angles. So that means your variable is going to be sitting in here. And I used an x here. We'll use theta again today, but I used an x in here. Now the question becomes, how do we free up this variable? How do we solve for it? Well, we solve for it by doing an inverse sine. That's got that little -1 above it, okay? And the setup for today is going to be inverse sine of a number equals an angle. So notice over here, it was right here. It was the angle equals a number. Here it's the number equals an angle. So those two have switched. Okay. So we'll be setting up today problems that look like this. Inverse sine of a number equals an angle. And what was this number in here? Well, that's where our opposite over hypotenuse is going to go. Or the inverse cosine of a number equals an angle. Again, what was that number in there? What will it be? It'll be our adjacent over hypotenuse. Or the inverse tangent of a number equals an angle. What will that number be? It'll be our opposite over adjacent. So today we'll be doing some kind of an inverse trig function. And we'll have a number in here, an opposite over hypotenuse, adjacent over hypotenuse, and so on, equals an angle. So they switched. Here it was an angle in here equals a number. Here it's a number equals an angle. Okay. Now here's our first example, and I marked all over it. So here's what it looked like to begin with. Okay. So we have to find an angle. We got to find this angle down here in the lower right. So that's the first thing you need to do. You need to recognize here that you're finding an angle. Okay. Now we'll still start this off the same way. We'll, just like you did yesterday, we'll say, well, where's that 5 at in relation to that angle? Well, it's opposite of it. And of course, what's this 11 that's across from the 90? Well, that's the hypotenuse. So you'll say to yourself, what uses opposite and hypotenuse? Well, that's sine. That's SOH. S sine equals opposite over hypotenuse. So we'll set this first step up just like you did yesterday. It's the same as yesterday. You would say with this triangle and this information, you would say the sine of theta equals 5/11. So that's the first step there. It's just like yesterday. Now here's where it gets new. Now we're going to say, okay, we got this sine of theta. How do I get this theta out of here all by itself? Well, I got to get rid of this sine. Okay, how do I get rid of a sine? I multiply by an inverse sine. Just like if we had 5 times theta and you said, how would you get rid of 5? Well, you would divide by 5 because multiplication and division undo each other. And we would get an answer of just theta. The theta would just fall down. So here's the same thing. We have a sine. How do we get rid of it? We do an inverse sine. That allows me just to cancel those two and let this theta fall down. Now, since it's an equation, if I do an inverse sine on the left, I have to also do it on the right. So I end up with here on this next line, theta, because these two canceled, theta equals the inverse sine of 5/11. And now we know what we need to plug into our calculator. Now, where will you find this inverse sine? Well, if you go find your sine button, look right above it. At least if you have a calculator like mine, okay? It's right above it, which means we're going to have to hit the second button. I believe on an iPhone calculator, if you rotate your calculator into landscape mode and hit a second button on there. I think there's a second button when you rotate it into landscape mode. It'll show up inverse sine. So we plug this into our calculator, and we'll go ahead and go 1 decimal. This one happens to round to 27.0, so you could just say 27 degrees. But now realize it is an angle, so we should remember to add a degree symbol because it is an angle. Okay? Now our next example, again, we need to get in the habit of looking to see what are we finding, and it's one of two things. It's either a side or an angle. We're finding an angle here. Okay, so in my head, I know I'm going to have to do an inverse function, so I'll have to hit the second button in my calculator. But we would want to know where our information is, and I made a mistake here. I went over here and labeled this and didn't need it because there's no number down there. I needed to label that 7, which is adjacent, and of course opposite of my 90 is my hypotenuse. So this one is working with an adjacent and a hypotenuse. That's cosine, that's CAH. So if I would have put this problem on yesterday's homework, you would have set up cosine of theta equals 7/13. So that part, again, step 1 is from yesterday. Now how do we get this theta out of there? If it's a cosine, we do an inverse cosine. If we do it to one side, we have to do it to the other, and that's a good thing. That tells us what to punch in our calculator. There's what we punch in our calculator. We'll go 1 decimal place. I got 57.4, and then remember to add your degree symbol. So the moral of the story today is label your adjacents, your opposites, your hypotenuses, just like you did yesterday. Figure out which one you're using. Get this first step set up. Then the new thing from today is how to get this theta out of here sitting by itself. How to get rid of this cosine. Well, here's what you do. You multiply by the inverse cosine. Then just make sure you punch things into your calculator correctly, and the calculator will do the work for you. Okay? Now tomorrow, there will not be a video. I think I'll just make up a Google form combining finding sides and finding angles. Give yourself a little bit of a quiz, kind of, can you keep them straight and can you do both forms? Hope everybody's okay. Everything's good here so far. Stay strong, stay healthy, help out around the house. Okay? We'll talk to you later.